The expression, as you see here, is simplified by expanding it and combining like terms. How many terms are in the simplified expression? Obviously, this would be horrendous expansion. Horrendous. Let me tell you, I ran this on Mathematica before I started explaining this about 30 minutes ago, and it's still running. So I think we will finish this before Mathematica does. So that's how horrendous this is. Unless we see some pattern and avoid work, there's no hope of doing this. I mean, can you do it faster than computers? Okay, now how do we do this? We got to see the pattern, and you will see, it's going to cancel something, but I don't like expanding trinomials. How can I avoid doing that? First, you see this as a binomial by saying that this term is W. So we got 2006 plus, and we have x minus W to 2006. Okay, what are we going to get? Where anytime the W is, by the way, do you see it is, if I call y plus z to be W, then we get this substitution, you see, right? Okay. Anytime a W gets an odd power, it will cancel with this thing, right? Because this one have a positive, this odd power will give you negative. So you would only have the terms that are positive, I mean the even power. Because when W is odd power, x will be odd power too. So I'm going to ignore the coefficients because we don't care about the coefficients in this problem. We just care about the number of terms. And also, even if I cared about the coefficient, I would not know what they are. I just know the first two. So here, I wrote W. So let's see. The first guy would be x to the 2006, right? Plus, I'm ignoring the coefficient. I will have x to the 2005 times W. And then it would be x to the 2004 and W squared. And so on until we reach x to the 1, W to 2005, and W to 2006. I ignored all the coefficients. Okay, now I'm going to write the second guy here. Second guy would be x to the 2006 minus, right? X to the 2005 W plus da-da-da, minus da-da-da, and here would be minus x to the 1, W to the 2005 plus W to the 2006. If you add this, I ignored the coefficients, but they are the same numbers that I do not know of. Oh, I know this one is 2006. After that, I don't know. But they are the same numbers. So this would cancel, this would cancel. The survivors will be 2 times what? X to the 2006 plus, I'm ignoring the coefficient, x to the 2004 W squared plus x to the 2002 W to the 4th, until you reach W to the 2006. Okay. We only care about how many terms we have. If we look at this, it's 2007 terms. No problem. No. It's a 2000, half that. Okay, first of all, let's see how many terms we got. Okay, we have the x to the 0th power, or it doesn't matter which way we look at it. I see. Okay, let's look at x here. X to the 6th power, x to the 2006th power, x to the 2004th power, 2002 power, 2000, and goes to x to the 0th power. Oh, how many numbers are there? I'm going, 0, 2, 4, until I reach 2006. Wow, how many numbers are here? There's an easy way to do it. Let me show you. Let's see. Suppose I take these 3, right? How many numbers are there? 3, duh, right? But thing is, it's going up by 2. So what you do is this. You take the last one and subtract the first one. 6 minus 2. Then it's going up by 2, so I will divide by 2. What do I get? I get 4 over 2 equals 2. But I have 3 numbers, so you got to add 1. So 3. It's simple as that. So I'm going to subtract the last, the first from the last, and divide by 2. It's 1003. Now I got to add 1 to count for the 0th power. It's 2004. 1004. This is a sloppy way of writing. It sounds like this is equal to that. No, I didn't mean that. This is 2003, so I got 1004 terms in here. Okay, 1004 terms. But that's not the answer. Obviously, it's not. Each one has W in it, which the problem didn't have. We made it up. And we are going to expand this W business here. Okay, how big is it going to be? First of all, do you agree this multiplying by 2 in front would not affect anything about this number of terms? It would be exactly the same number of terms after you multiply by 2. So I will ignore that. Okay, now what do we have here? I got 2006, right? X to the 2006. And nothing will happen to it because there's no W in it. What about this? I have X to the 2004. And I have to expand this W, right? Which is y plus z to the second power. How many terms would this give you? It will give you 3 terms. When you have binomial expansion, the number of terms is always one more than this. So this would give me 3 terms. So this was 1 term. This would give me 3 terms. Okay, now what about this guy here? X to the 2002 and y plus z to the 4th power. This would give me 5 terms. And what about this thing multiplying in front? Doesn't make any difference. You just have 5 terms being multiplied by this on every term, so still got 5 terms. As you can see here, you will be having 7 terms, da-da-da, da-da-da. So basically, you will have this progression of the 1, 3, 5, 7, and you will have 1004 terms. Ah, how do we compute that? Well, so we are dealing with, so we are going to 1004 terms. So let's do it. I equals 1 to 1004. Okay, this is arithmetic sequence. And so I would be 2i minus 1, right? Agree? So that would generate this. So let's use the property of summation to make this a little easier. I got 2i equals 1 to 1004. I pulled out the constant minus I equals 1 to 1004, 1. Okay. All right, the first one, let's do the second one. I'm adding 1 to the 1004 and times 1, so the answer is adding 1 this many times. So the answer is 1004. So that's 1004, simple enough. And here, how do you do this? Well, it's always the first number plus the last number sorry, that's right. And then, how many numbers we have? We got 1004 numbers divided by 2. That, except I got 2 in front, that will cancel with this. There was 2 in front and canceled it. And then I'm subtracting by 1004. Okay. So what would this give me? Let's see. Do you see? If I distribute 1004 here, that will give me 1004 minus 1004. That would cancel. So all I get is 1004 squared is the answer. Okay. That guy should end in 6. If I scan the horizon, this one and this one does. Okay. How about some other numbers? Can you tell this is the one? I don't think I need to do this. You see it as 1000 plus 4 squared. So a squared plus 2ab plus b squared. A squared plus 2ab plus b squared. I hope you see it. If you don't, try it yourself. Then you will see it comes out to be this. So the answer is D. By the way, Mathematica is still running.